Alright guys, getting ready to start our next unit here, and it's probably going to have at least 2 videos. This unit's about the atmosphere, and atmosphere, pressure, temperature, and all those relationships. There's going to be a lot of relationships in this unit. So here's your learning targets. Take a moment to pause this and write those down. Okay, some questions I want you to think about. What are the major layers of the atmosphere called? What do you think the Earth's atmosphere, or how do you think the Earth's atmosphere helps you stay alive? And what are the gases that make up the air we breathe? Those are all going to be questions that I'll need you to be able to answer at some point during the first part of this unit. So the atmosphere, basically it's just the layer of the gases that surround the Earth, kind of like a blanket. It extends from sea level to the edge of space, and it gets thinner and thinner as we go up. Even in the upper atmosphere, near the edge of space, there's still some gas molecules, but those molecules are so far apart that we basically say that there is no air at the edge of space. Here's a little graph or a graphic that's going to show you the relative amount of air pressure at sea level up until where there is no air pressure. So the unit, kilopascals, is one of like 5 different ways of measuring air pressure. Don't get all hung up on what that unit means, but just realize that as the numbers are bigger, then there's more air pressure. So at sea level, there's 101 kilopascals. That's normal air pressure. Jets fly at this level, which is somewhere about halfway between this number and this number. Mount Everest only has about a third of the air pressure at sea level, and then when you get to a certain altitude, air pressure will cease to exist. There's no air molecules. This is the gases that in the air that we breathe. We breathe about 78% nitrogen, 21% oxygen at sea level, and then carbon dioxide, water vapor, and other trace gases make up 1%. Which one of these gases do you think has the most impact on our weather? You know, we obviously know which one's most important to us to stay alive. Which one do you think has the biggest impact on our daily weather? Think about that. We'll talk about that in class. So what happens to air pressure as we increase in altitude? Well, it goes down because the amount of air that we have pushing down on us gets less and less. So you can see this in this graphic, the altitude. Look at the red line. As air pressure at sea level is pretty high, as you move up in altitude, the air pressure goes lower and lower and lower, so it curves back to the left. Air pressure is simply the weight of air pushing down on you, the weight of air above you. So what happens to temperature as it changes in the atmosphere? It depends on what layer you're in. You know, there's different layers of the atmosphere, which we're getting ready to look at. In our layer that we live in right now, the troposphere, the temperature decreases with altitude, but that changes with each level, and that's something I need you to learn. So here are the layers of the atmosphere. The first one's called the troposphere. That's where we are now. It's a relatively thin layer. It's only about 14 kilometers thick. Extends from sea level up to 14 kilometers. And it contains 90% of all the gas in the atmosphere. It also contains all the weather. And as you increase in the altitude, the temperature decreases. It gets colder as you go up. Next layer is the stratosphere. It's from 14 kilometers up to about 50 kilometers, so it's thicker than the troposphere. It contains most of the concentrated ozone in a layer, and that's very important. It keeps us alive by filtering out a lot of the dangerous ultraviolet sunlight. There's been a problem with ozone depletion. There was a problem for decades and decades and decades, and we're starting to get that under control. Human activity has thinned this layer, especially over the South Pole. This part of the atmosphere is where the jet stream exists. Jet stream is that high-speed river of air that pretty much brings storm systems to our part of the world. In this layer of the atmosphere, the temperature increases as the altitude increases. The mesosphere, this is called the middle sphere. Meso means middle. It's about 30 kilometers thick. It extends up to 80 kilometers. And just to give you an idea, meteoroids, which are little particles of dust and rock, actually burn up in this part of the atmosphere, and this is what you see, where you see the shooting stars. And in this layer of the atmosphere, the temperature decreases as you increase in altitude. So far we got a decrease, an increase, and now we got a decrease again. The thermosphere, you probably realize that thermo means heat, except it would be very, very cold in the thermosphere. We'll talk about why when we get into class. But look how thick the thermosphere is. It's about over 500 kilometers thick. This is where you're going to see the interaction between solar particles and our magnetic shield, called the northern or southern lights, the aurora borealis in the north and the aurora australis in the south. And in this layer, the temperature doesn't flip-flop again, and it increases as you get higher. This layer also contains the ionosphere, which sometimes can help or hinder radio communication. So here's a picture of the northern lights. This is cosmic rays, radiation from the sun interacting at a certain angle with their magnetic shield. The exosphere. This is sometimes called a layer of the atmosphere by some textbooks and sometimes not. This is where the atmosphere meets outer space. There's almost no air particles here, so it's anything above 600 kilometers, pretty much you're in space at that point. So here's a nice diagram that we're going to get very familiar with. It's going to tell us a bunch of things. It's going to tell us just about everything that we mentioned in this presentation. So we'll look at this more in class. And that's it, guys. Thank you.